Yo, testing 1 2 3. Testing 1 2 3. Testing. Yeah, both neither of those films are Marvel films. Neither Venom nor Spider-Verse are Marvel films. Testing 1 2 3. I think we're ready to come back online, if I'm not mistaken. Finally, for a new day of streaming. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. Yo, it's Season 2, Intro to Python. We are working on a text-based adventure game. It is coming along really well. Today's our final episode, though. We're going to do some finishing touches here. Of course, it's not going to be no Zork after 6 days, and all those 6 days are spent mostly explaining and re-explaining some basic concepts, because I'm kind of gearing this toward total novices. That being said, it's looking pretty decent so far. Let's have a look at it. First of all, though, guys, we're enjoying very, very quietly the music of my friend Albdat here on Twitch. He's called Flaming Blizzard, twitch.tv/Flaming Blizzard. He has no Twitter anymore. I guess he nutted up and deleted that shit, like I think most of us probably should. I like my Twitter, though, whether or not it's healthy in my life or not. And we have his new album here at Albdat, A-U-B-D-A-T. That's his musician name, A-U-B-D-A-T, albdat.bandcamp.com. Go check it out. Free music. His new album, Aux Victimes. It's like a little EP. It's godlike. I enjoy it a lot. It's a little bit more rhythmic and harmonic than most of his stuff is. Not quite as ambient. Still very, very ambient, of course. Very cool musician. Very great for programming, I find, and doing homework, that kind of thing. It's very relaxing. It's free, or you can pay what you want for it if you want to help him out. I think it's definitely worthwhile. I'm going to go kind of move the Chrome browser to the Python documentation. I might use that, probably not. Just in case, though, let's bring this up and then minimize it. We got our game as it is right now. Let's go. So Faust says, I might actually go take a shower. I feel kind of gross. Go take a shower, Faust. I recommend it. Python day. First of all, is your toolbar on the left side of the screen? Yeah, it is. Yosh. It defaults to that. Why do you make fun of me for that? I just leave it the way it was at default. That's what it does. I thought you people were just a myth, folklore. That's the Windows default. What do you want from me, Bones? What do you want from me? That's the way it's set up on Windows 10 these days. This goes on to the left side. Yes, I got used to it over the past couple of years. I used to do it on the bottom. This my ex-girlfriend didn't like me. Okay, so let's see here. So our game's kind of like a Zork-style game. You start off in a cave, as you can see here. It asks what you want to do. We can look around the cave, right? It says you were in a dank cave. There is a torch and a door and a treasure chest here. We can get the torch. I think it's get the torch, right? Yeah, get the torch. You can use that to light up dark areas. You can open the chest. Right, there's stuff inside the chest, including a key, a delicious calzone, and a screwdriver. We can get the key from the chest. We can unlock the door after that, and we can open the door after that, and we can enter the door after that. Right, we can look around. Now we're in a new room. It's a very, very simple adventure game, but for a total novice programmer, I feel like it's kind of interesting. It's kind of exciting. Right? Get torch. So speaking of get torch, Bones, today we're going to be doing something a bit different. In our last couple episodes, we've been moving from our old functional programming style, which had all of our data and operations, the two halves of any program, kind of floating around in an ether. Right? In functional programming, you kind of define your data, and you define your functions, right, your operations, and then you just use the functions on the data. Right? It's very simple, and that's why it's still very popular to this day, functional programming, because it's so simple. It makes it very hard to accidentally put bugs into your code, right? Because it's so simple. But most modern programmers use a paradigm called object-oriented programming, where instead of just having your data and your functions, right, and just having them kind of just interact that way, you instead have conceptual objects, things that represent like nouns in our English syntax, right? It's like things. And in our case, look at our code here. You see we define some types of objects, such as a treasure chest, right? We've also defined a door. Right, we have defined stairs. Right, we have defined the player. See that? So basically, the reason why object-oriented programming is so popular these days compared to functional programming is that usually when it's a way to combine your data and your functions, right? Your data and your operations, which are the two halves of programming. It helps you break very large, complex programs into smaller, more manageable pieces. And it also makes your programs much easier to extend and add to, because you can very easily manufacture the objects that you've defined. So for instance, right, instead of having our old functional way of programming, which was to define a player and then define a do a dance function to make them do a dance. Let's go try that right now, in fact. Let's go here to our Python shell. We're going to do a dance. There you go. We performed a break dance. Right. So before we used to do this by having a player object we defined and a function we defined that were totally separate. This function was called, do a dance. then we would run do a dance on the player. Right? We would say do a dance and then use the player to do that. Right? That's the functional way of doing it. However, the object-oriented way of doing it is to define the player and say the player can do a dance. Right? So we're not saying that we have a do a dance function and we run it on the player. That's functional. Here we're saying we have a player and it does a dance. And as you can probably imagine, that's a bit simpler for human beings to understand, right? Because that's kind of more how we see the world, right? As a bunch of objects that do things, right? Or have things done to them. So we define these objects, right? We still have a few more to define. But basically the way we're standing right now, that makes sense, right, Bones? But again, the problem with object-oriented programming is that because you have these objects that have traits, right, such as the player has his inventory, right, and he has his position as well, that means that these traits can change over time. Whereas in functional programming, you define data, and you run functions on that data. But what functions do is they take in data and spit out new data, right? So they'll take in 1 and 1, and they'll spit out 2. Right? That kind of makes sense, right? It makes a lot of sense. And for that reason, functional programming is very clean. It's like it's like a pipeline. You send things into the top of the pipe and things out the bottom of the pipe, right? It makes sense. But object-oriented programming is a little bit different. In object-oriented programming, you have these objects and they have traits. Just like in real life, like objects have traits, right? Like people have traits, furniture has traits. All these objects we think of have traits. And just like in real life, these objects can have those traits change, such as our player, right? He has a position. It starts off as being nowhere, but as the game goes on, his position changes. He has an inventory, and as the game goes on, his inventory is filled with things, and things are removed from it, right? And that seems simple enough, but what's dangerous about that in a very large program, like let's say we have tens of thousands of lines and huge databases and it's really complex software, is that when you then do something to the player, you say, hey, I'm going to take this object and manipulate it. It's kind of hard to know when you have such a huge program exactly what is being done to that object, because you don't have a simple function that takes data in and spits data out. You have a function that takes data in and then it messes with it. And then, nothing comes out at the bottom. Nothing comes out of the bottom of this tube. Things go into it, and then those things are messed with. And you can still use that, that thing that you put inside, but you're not exactly sure what got changed. Now, of course, as a programmer, right? You would think that. You would think as a programmer, If you say, take a fence and put it into this paint red function, right? Paint red. Well, you know that it's painting the fence red. The fence's color trait has changed to red. But what's crazy about that is that when you have, 20 programmers working on one program, and they're all messing with these objects, then you might be surprised that you, let's say, put your fence function into paint red, or your fence object into a paint red function, and yeah, it comes out red. But later you find out that the fence won't get soaked anymore. You're like, why is the fence not getting soaked? It's raining. Well, because it turns out somebody along the line messed with that paint red function and also, waterproof the fence in there. And it's called paint red. You think we just paint it red, but it can do anything. When you feed an object in object-oriented programming into a function, that function can do anything to that object. So it can be very difficult to keep track of what's going on, and it can be a major source of bugs, which is why a lot of programmers still prefer functional programming, where again, you just put data in, get data out, and nothing ever gets changed. Right? Just whatever you put into the top of a function gets destroyed, and then whatever comes out the bottom is your new stuff. And that can be very powerful, but it is much more difficult, and it's not very popular these days. It's still kind of popular. What's up, Wade? Val says, no hecking way, there's a 9.5 hour run of FF9. This is GDQ. 10-hour run of FF9? That's crazy. Faust live from the shower. Says, my phone is waterproof. Be careful, Faust. Don't slip. You're getting so excited about this GDQ FF9 run. Okay, so I've described, briefly, from the perspective of a novice, what's cool about object-oriented programming and what's not cool about it. Right? But again, it's the most popular paradigm by far for programmers these days. We're kind of evolving past functional programming as beginners, because that's kind of easy to understand as a beginner, and moving more toward objects, which are much easier to understand as an intermediate level programmer. They're much easier to organize large programs with, for better or worse. Again, they kind of have their downsides, but they're usually for the better, I think. In any case, what do we got here for our objects we've defined? We have game areas, which are like rooms, essentially, right? Such as our entrance to the cave and the dark room. These are like rooms, right? And in these rooms, they have some traits. The description, you are in an area is the default description, and whether the room is lit or not. Right? If it's lit up, then you don't need a torch. If it's not lit, you need a torch to see what's going on in there. Then we have this method, it's called. Again, objects have attributes, which are like the equivalent of data in functional programming, like variables, but they belong to this object. They're traits of it, they're attributes. So the data of an object is the attributes, and the functions of the object are called methods. They're just like any other function, except that they belong to this object. Right, so it kind of helps you organize your code a little bit. So the areas have this get description method, where it helps you spit out the description of the room you're in. And first of all, when you try and get the description of the room, it checks to see if the room is lit. Right? If self.isLit, so in other words, if this isLit attribute of this object is true, or the torch is in the player's inventory. So if the room is lit, or if the player has the torch, then print out the room's description, and then for every item in the room's inventory, print out there is an, then the item's description, then here. So for everything in this inventory of this room, print out, there is a torch here, there is a chest here, etc. Jake says, does co-op start soon? I think it does, yeah. Yeah, not much I can do about that, I'm afraid. So I stream here, 8 hours a night, 5 nights a week. I thought I'm probably going to miss it. I'll probably have to watch the recording of it later. What's up, JSK Epsis? JS Kepsis, maybe? Fast says, I actually haven't left my desk yet. Mentally preparing myself for the 20 pounds of water my hair is about to soak up. Dude, I hate getting in the shower, but I love coming out of the shower. You guys can feel me on that? You guys probably feel me on that, I think. Oh, is it Saturday and Sunday, or does it start on Friday? Oof. Chunli didn't want to run back. Wait out your body and chuns. Yeah, Faust knows. I hate getting into the shower, but I love getting out of the shower. If you don't have it says here else, right? Else is like the other fork in the road. If the if did not trigger because self.lit was false and the player did not have the torch, right? So the room is not lit, the room is dark, and the player has no torch, then we say else, right? This isn't true, so else print, it's too dark to see. All right, so if the room is not lit up, you have no torch, just prints off, it's too dark to see. You don't get the room's description, and you don't get the inventory if you can't see in there. You also have this treasure chest object. It has an inventory, right? It has an is open value. It has a description, right? And it has this open lid method. We can open the lid of the chest. You can take items out of it. What else we got here? We got this door. It has quite a few attributes. You can, the door has a state for whether it's locked or not. It has a state for whether it's open or not. And it has two locations, location A and location B. These are both sides of the door, right? So when you enter the door, you go from one side to the other. Right? So it has two rooms attached to it, basically. And it has a description. In this case, it's just door by default. You can unlock the door with this function here. It checks to see if you have the key. And if you're close enough to the door. And it has this open up function for opening the door if it's closed. And it has a state for this method for entering the door. Right? So you can go from one side of the door to the other side. Let's go, Wade. Shower party in the chat. Shower party in the chat. Faust showering. Wade's showering. I'm just out of the shower. Gotta get bones in the shower. I can smell them from here. So yeah, Co-op Cup is supposed to start in like 10 minutes. Oh. I think a lot of my 3S viewership is probably not going to be too interested in Python today. For some reason, my brain didn't make the connection to, I'm sorry, I can't really see I'm actually going to raise it up like North Carolina a little bit. Oh, to the Japanese Times, I gotcha. Bones showered when he got home, but I guess back in I go. It's all right, Bones. You showered when you got home, that's fine. I'll let it slide. Thanks for the follow, Asylum of Mind. Kind of a cool handle. A little bit Hot Topic-esque, but that's cool. I'm down with that. I grew up in the 2000s. Welcome aboard, homeboy. We do programming here on Friday. We look at variety stream, play a lot of gameplay here. Street Fighter gameplay, some Smash Brothers, some retro games. But starting next week, it's going to be much more focused on programming here. Welcome aboard, man. If you have any questions, let me know. Yeah, Faust says, I still have 2 or 3 Hot Topic rewards cards. Let's go. What are you going to buy with them? Maybe like a Batman the movie keychain? Or one of those leather bracelets with little studs on it? Wait, is Hot Topic even still a thing? Hell yeah, it is, dude. That's why we gotta go get your Kingdom Hearts merch these days. You can go there and buy some Jack Skellington purses and some Kingdom Hearts stuff. That's what you want to do, right? Because it can't still be a thing. Oh, it's a thing, dude. Trust me, it's a thing. So we have a player object. Here's an inventory, which is a problem. I'm going to talk about this in a second here. We have a bug here, guys. Here's a position. And he can do a dance. He can look around. Right? And we have these game items. These are just generic items that really have no purpose aside from being moved around from room to room. Right? This includes the key. This includes the torch. It includes the record and the calzone and the screwdriver. These are just things that are just around, and the player can pick them up and that kind of stuff. And that's all of our objects right now. A very simple game. We're very simple programmers still, right? We're still beginners here. So it's kind of like a very, very simple setup. We have a lot of work to do today, though, to get this kind of wrapped up. Wade's, I remember the pants with the straps, yes. Probably still get those there. The trip pants, huh? The early 2000s of bell bottoms. Yeah, those really huge pants. I love those too. That was my time, dude. That was my time. That was high school for me. Okay, so let's look at a bug we have first of all. Right? I know it's kind of abstract. I haven't really demonstrated much of the game today. But before we even get started, really, I want to address a problem that we introduced last time by using these class attributes. Okay, I want to emphasize the difference between a class, right, such as our game area class, and an object, which is an object that is manufactured from a class. You can think of a class like a mold. Right? The class is like a mold, basically. And the object is what is made from that mold. So when we define this game area, right, we define this game area here, it has all these traits, right? It's just a mold for a thing. And then down here, we're going to manufacture a bunch of game areas from that mold. Let me demonstrate that, see? Right here, we have the cave entrance, right? It's a game area. Let me change all the stats of game entrance, like all the attributes, like the description and the inventory. And we add some stuff to the inventory, right? We also have this dark room game area. We use the the game area class or the mold to manufacture this object, the dark room. Let me change its attributes, right, from the defaults. We have this basement as well. Those are our 3 areas right now. They're all 3 game areas. Now, when you call a class name, like game area, and you use these these parentheses, right afterward, that's how you make an object. That's how you kind of make an object from that mold. So you're saying, hey, take the game area class, and then instantiate is the word. Instantiate a new game area. And we're going to call that dark room. And it's called instantiation because the object itself is referred to as an instance. Right? We have this instance of game area. That means we're making an object from that mold. So we're instantiating it here. We're making an instance. The fucking burnouts all wore JNCOs with the wide flare legs. They were goth emo kids thing where I'm from. They were a goth emo kid thing here. Yeah, exactly. They definitely were. They definitely were. Those are the good old days, man. Okay, so let's talk about instantiation. Right? Because we have a bug here. As you can see, when we define our game area, we are also adding an empty list to each game area and calling it the inventory. But how come we don't just do that up here? Right? How come we can't just say game area inventory equals an empty list? Just give it a one right off the bat, right? By default, that makes sense. Well, here's the problem. The problem is that when you define these bits of data within the class definition, right? This is the class definition, right? We're defining the class. These become associated with the class itself, not necessarily with the individual objects that we're making out of that class, right? These are attributes of the mold, not so much of the objects we're manufacturing from that mold. So for most cases, that's fine, right? If the mold says you are in an area and you make an object out of that mold, then now that object has this description, you're in an area, right? So that makes sense, it works, right? But here's the problem. The problem is when you have data that can change over time, such as an inventory, right? This is a list. Now, lists can have things added and removed from them, right? So this description here, this string is called, the text. You cannot change text once you've created it. It's what's called immutable data. You cannot mutate it. It's immutable. So when you define this text, sure, you can chop it up into pieces and then make another string out of that, another bit of text out of that, but that original text is always whole. The text is always the same. And same as its Boolean value. True is a Boolean value. There's true and false as Booleans. Sure, you could change the Boolean that this name isLit is associated with. We could say isLit equals false later, right? But that just means that we're defining a new value, false, and then replacing true with it. We haven't actually changed that true. We just replaced it. That's not true for things like lists and dictionaries, because once they're defined, they can be changed. So our problem now is that if we're saying that this class has this list as an attribute, then every mold, every object we manufacture from that mold has that same list as the inventory. So if we try to add an object to the inventory of one room, it's added to all the rooms because they're all sharing this list together. They're all sharing this list. So that's kind of a drag. We want to have each room have its own list that's unique to that room. And we can't do that by using a class attribute. So what we're doing down here is we are, after we define the room, each room, we're giving it its own new list, right? We're defining a new list for it right here and giving it to the inventory name. But there's another thing we can do, right? There is a much more elegant way to handle this through instantiation, right? And that's by using a magic method that all classes have. We haven't talked about that much yet. Those goth girls, though, I totally agree. Give them a pack of clove cigarettes and they're all yours. Wow, Wade. Wade remembers. Oh, my Lord. That was some 2000 shit. Sometimes I wonder if it's worth it to get original Jarum cigs illegally sent to my house from Singapore. Also, 2000s goth girls love? Absinthe. Okay, so here's what we're going to do, guys. We're going to use a magic method. So in Python, there are some pieces of data and some operations, the two halves of any program, right? Data and operations, that are magical. You can always tell a magical function or a data because it starts with 2 underscores and ends with 2 underscores, right? I'm going to give you guys an example. What makes them magical is that they have behaviors that are not like other pieces of data and other functions. That makes them magical. For instance, we have this bit of data called name, right? This data here, name. You can see it starts with 2 underscores and ends with 2 underscores. And what name is it's the actual, it's the name of the function that this code is running in, right? So even though we haven't defined name like you would with other pieces of data, it actually has a use that belongs to Python, basically, right? You don't fuck with it yourself. You don't fuck with magical stuff most of the time, but it does have a purpose. So name means the name of the method that you're running in currently. But I want to talk about a magical method that we do use a lot as programmers in Python and other languages as well. Right? It's different in other languages the way that works, strictly speaking, but every language has something like this, and that would be a init function, right? A function that is run when you instantiate this class. So we're going to make a new method here. We're going to call it underscore underscore init underscore underscore. And like any method, the first argument's always self. It always gets itself as the first argument. That would be the object we're manufacturing. And what init does, I'm just going to put a pass here for now. Pass means it doesn't run anything. What init does is that it's a function that runs when you manufacture an object from this mold. Init always runs when you manufacture an object, basically. So if you look down here, we talked before about defining a new game area, how you manufacture them. I said that you use the class name, and then you put these parentheses on the end. That will manufacture a new game area, and we can save it to this name right here, cave entrance. But what's really cool about this little parentheses here is that it's not strictly that simple. What we're actually doing is we're calling a function, As you guys know, when we call functions in this game, we always use parentheses. And we put in arguments in between those parentheses, right? We use the function name. Then we put in, parentheses. That means call the function. Then we supply some arguments, some data for that function to use. But here, when you define an object based on a class, you're actually secretly calling a method on that class. Right? That's what makes it magical. What you're actually doing is you're calling this. That's what you're doing by when you actually put these parentheses on the end. Right? So game area is the name of your class, right? And when you put parentheses on the end of the class name, you are actually calling the init function. Basically. Not exactly, but basically. So, what we can do is we can actually define an init function in our class and have it do some cool stuff when we make an object. For instance, we can actually have it automatically give us a description and an inventory and whatever else we need. Right? So let's go do that. Right here. So we have this init function, right? And we're going to actually just say self.inventory equals an empty list. Right. Now what's cool about this is that when you run init, it will run this code. So this code up here is ran when Python first defines your class. Right? That means that we get this one list, which is a bug, right? That bug will cause problems, like I mentioned earlier, because this list is now shared between all objects manufactured from this class. Right? We don't want to have one list. We want to have one list for each object, right? Not just one list for the whole mold. So by having this be moved down to init, what we're saying is when we make a new object, right? When we actually manufacture an object, then give that object, which is called self, right? Every method takes self as the first argument, which means the object we're making, right? Self is the object that we're making. Give that new object an inventory attribute and make that a new list. So because this code is ran every time we make a new game area, that means that every game area is now getting its own list. Right? It's not being run once and being defined up here one time. It's being defined repeatedly whenever a new game area is created. So now we have used init to save ourselves the trouble of having to give all these areas their own inventory manually like this. I can go delete these lines now. All these lines were giving them their own list for their inventory. Manually, that's now being done during instantiation, right here. So right here, now this dark room is getting its own inventory. So we called init right here. Okay. Oops. There we go. Also, when we're initializing things, we actually supply arguments. Right? So far, all of our classes have just been instantiated with no arguments. Right? We just have empty parentheses. But by supplying arguments to init, we can actually give them some arguments. For instance, we can give the argument of description. Right? So now we can say, self.description equals description. So whatever was supplied as an argument to the init function in this slot, right, our description slot, we're now assigning that data to our new object's description attribute. That way when we initialize the game area, we can give it a description, and it'll automatically be saved to that object. Right? We're saying our description is equal to whatever the user punched in as that first argument. I say first because self is the default. It has to be there. So description is really kind of like our first argument. Also, we can actually add even more. How about like we give it like that's fine for now. Let's do it like this, right? So we have this description now. So now we can actually save some text. For one thing, we know that every time we call init, we have to supply a description, right? That means we can get rid of this default. Fuck this default. Go away. Okay. Now we can go down here and we can save a line of code. That's why I did that. Watch this. So now the game area, right? It requires an argument. We know that. Oops, I have to fix this too. There we go. It requires an argument now. So now we can give it an argument here. The description is what we want, right? So we're going to say you are in a dank cave. That's our argument, right? The description. Now we don't need this line anymore. Boom. We can say here, surprisingly, you find yourself in a cozy room. Okay, I'm going to get rid of this line. And here we have, you are in a slimy basement. Boom. Got him. There you go. This cave is dank, that's what I'm saying. Hope you're enjoying it, duck butter. If you have any questions, let me know, dude. I'm definitely open to programming with you guys. In fact, I think that starting after next week, I want to have these streams be more interactive. I have kind of some ideas for that. If you guys want to be involved in learning Python, you want to actually have me tutor you a little bit personally, join our Discord at Vencabot.com. Go to Intro to Python. We have an Intro to Python text channel there. And let me know you're interested in learning, because I kind of want to get a team together of guys that want to learn. And we're going to do some really cool stuff, I think. Big screen TV, mini fridge, sectional sofa. And a cozy little room there. We can add all this stuff. We actually could do that. Why don't we do that real quick? We'll add the mini fridge at least. Let's go down here to our objects. What do we have here? We have like the record player, for instance. Let's make a mini fridge. Mini fridge is a game item, right? Just an object in the world. And then we're going to say mini fridge dot description equals, a mini fridge. Full of Slim Fast. There you go. So now this mini fridge, right? We're going to put that mini fridge in the cozy room. So where's our cozy room at? That's being defined right here, the dark room, right? It has, we're appending the door to the inventory, right? So it has this door in the room. We're appending the stairs to the inventory of the dark room. So that means we're adding stairs to that room. We have this record player being added to the dark room. We're also going to add this mini fridge. Darkroom.inventory.append mini fridge. That's what it's called, right? Where is that? Right here, mini fridge, yeah. There you go. So now it has a mini fridge inside there. Cool. Easy. Sometimes I don't know about interactive, but I sure as hell am learning something, however small it is. Have no clue about coding, but I'm trying to learn something new. Yeah, Asylum. If you go to our YouTube channel at Vencabot, that's youtube.com/Vencabot archive, or search on YouTube for Vencabot, you'll find an entire playlist dedicated to Intro to Python. This is our last episode of this season. So every time we stream Intro to Python, we kind of add new ideas to our program. If you go back to our day one, though, our day one of this adventure game, or even better, our day one of Pokemon, you will get ideas that are much more geared toward total beginners. Right? They're geared toward total beginners who have never programmed before in their lives, including how to download Python, how to use Notepad to write programs. And then every day we kind of add on more ideas. And this is our final episode of the season. So right now we're kind of complex. We're kind of complex right now for total beginners. But in the grand scheme of things, still very simple. Yeah, it's a pleasure having you, Asylum. File says, oh wait, apparently it's only legal for them to be sold inside the U.S. Oh, okay. Cool. Interesting. Okay, so we have this mini fridge now for no reason. I thought it would kind of be fun to add to that room. Just want to show off how simple that is. But I see now that if you look at our items here, we have all these redundant lines. It says, description is key, description is torch, right? We're defining these attributes, the description attribute, after we make the item. Why don't we define the description during instantiation? Right? Because every item needs to have a description. As you can see here, we define the item, then we describe it. Why not just have the description be a part of instantiation, kind of like our game rooms, right? Let's go up here to our game item class that we're using to manufacture these items from. This mold. Where is that? I think actually our last class, right? Right here. Very simple class, right? It only has one class attribute. But I want to actually make a method for it. We're going to define a new method. DEF means define a function, or in this case a method. Use our magic function init. It means it requires the underscores on both sides, 2 underscores. Give it self as the first argument, because every method gets self as the first argument. That's the object we're making. And then give it this description argument. Right, so now when we instantiate a game item, it needs to have a description as a part of the instantiation. Then we're going to say, self.description So this item's description equals whatever was supplied as the argument right here. Right? When you define a function or a method, you can supply these things called arguments, which are like things that the function needs to operate correctly. And what it needs is some kind of description here. Then you can use whatever's in that slot by calling it by name. So our description for this item we're making is going to be equivalent to whatever was supplied into that slot called description. And now we don't need this anymore, this default value. Now let's go down here and save some lines, shall we? So down here now we're defining these items, right? Now game item, the instantiation right here, requires one argument, which is the description. So now we're just going to put that right there, between the parentheses. Key is a description. Now we don't need that anymore. Torch is the description. Now we don't need this anymore. We have the vinyl record right here. Okay, get rid of that. We have the delicious calzone right here. Okay. So by using this mold game item, we are manufacturing many things very rapidly, as you can see. We're actually just making a ton of shit with this mold. And that's what's really great about object-oriented programming. Right? That's the reason why object-oriented programming is so popular these days, because you can just make one mold and manufacture a ton of things based on that mold. Gimpy code says, wait, so you don't need the variable description on your class anymore. Exactly, here's why. Because, let me go up here. Because these class attributes are called, the class attributes. They are automatically given, they're like imparted to every object that's manufactured from that class. Think of it as like a trait of the mold, right? It's a trait of the mold. And so when you make something from that mold, then it gets that same attribute, it gets that same trait. However, because we now require a description upon instantiation, that means that we don't need to have this here, and it's redundant, right? It's redundant. Like, let's do it again. Right. So our old code worked in such a way that whenever you defined a new item, it would automatically get this description item. Right? It would automatically get that. However, now because we require a description when you make a game item, there is no reason to have this default one, because every game item must have a description supplied. Right? It must have one supplied for it. Otherwise, this it won't work. You can't make one anymore. We can't. For instance, if I were to go here and try this code right here, game item, and then just call it with no argument. It's right here. It's no argument, right? Just empty inside the parentheses there. It would crash our program. It would say, hey, listen, you need to have a description because the init method of game item requires a description. So because it requires a description, we don't need this here anymore, because this is redundant now. Because every game item is going to get one anyway. It gets it right now. Exactly, userman, exactly. Trust me, I know. That we're kind of focusing more on beginner type stuff. I don't want to get into defaults yet. That's a slightly more advanced concept. A lot of the guys here are still kind of struggling with how arguments work. But yeah, indeed, userman is correct. There are ways to do defaults. What he's saying is I could do this. I could say description equals item. And that means that now this argument here is optional. But I don't want to fuck with that quite yet. From now on, for today, every argument for a function or a method is required. But in the future, you guys want to get stronger in Python, you can actually make them optional. It's kind of cool. You can make them optional. Okay, let's see here. So yeah, we're removing the class attribute there because now it's redundant. Because now every game item instance automatically gets its description from the init method. You have to supply a description, otherwise it won't work. So you don't need that default anymore. There is no default. You have to give one. So at the screwdriver now. Welcome aboard, userman2. That is a really, really dry Twitch handle. I love it. Very, very dry. We have the old record player. And we have the mini fridge full of Slim Fast. Obviously. Best items that it only has a description exactly. They're very, very simple. All these are really for right now is kind of moving from the inventory to the room and vice versa. I'll get rid of this too here. So we save some lines. Made our code a bit more clear too, right? Made our code a bit more clear. In the sense that before we would make a generic object, We would make a generic object, then supply it a description, right? But now, when we're instantiating it in the first place, when we're making it in the first place, you can tell what it's supposed to represent on this one line of code, right? Because it says the name right there, has the description right there. It's a little bit simpler to read. We know that we're just making a bunch of items right now, and they have these little short descriptions. Very simple. Okay, cool beans, dude. Cool beans. I'm not sure what uptime is supposed to be. We have no bot here, user man. We've been up, what, since, for about an hour now. A little less than an hour. We're going to be streaming this Intro to Python for another hour. Until around 8:30, 9 o'clock-ish p.m. Eastern time. That's GMT minus 5. Okay, so what else can we do here while we're simplifying things, right? We have this, we're using the init method now, basically, to simplify a few things. Well, we have this player object, right? It has this list. We talked before about why it's a bug, right? This can cause bugs. If you use a mutable object, that's an object like a list or a dictionary that can be mutated, if you use that as a class attribute, that can cause problems, like with our game area. Now, it's not such a bad thing for the player, because there is only one player, right? So if all the players in the game share one inventory, it's not a big deal, because there's only one player to share it with. However, it is still kind of sloppy. Why don't we instead use init for this? When you initialize a new player, then they get an inventory, right, which is an empty list. And that's fine if we leave their their default as nowhere. And again, like Userman said, this is really kind of a whack way to do defaults, but I really wanted to kind of stress, how class attributes work. The fact that they're imparted to every instance that's made from them. That bug got me bad once, yeah, it's pretty tricky, especially when you're a beginner. So I'm sure a lot of, pretty much every programmer out there has had that happen to them as a beginner, where they've tried to use a mutable object as a class attribute or something, and then we're surprised to find that they were all being shared by every instance of that class. Okay, so what else we got here? We have the stairs. So right now, these stairs, for instance, they take, they default their location A and B, which is, the bottom and the top of the stairs. They default to a random game area. That's some pointless game area, right? Which is a bug now anyway, because the game areas require a description now, right? This is a bug. It's a crash our program. This empty instantiation. So why don't we just, because we know every staircase needs to have a unique top and bottom anyway, why not just have it be required upon instantiation? We're making an init method. It starts off as self, right? It's the first argument of any method is self. That's the object we're making. Then it needs to have a description. It needs to have a location A and a location B when you define it. So all we're going to do is we're going to assign these values, these arguments we supplied. Right? We have these three arguments. We're actually just going to attach them to our object. So self.description equals whatever was supplied as the description. Self.location A equals whatever was supplied as location A. And self.location B is whatever was supplied as location B. And now we can get rid of these here. Boom. Okay, let's go change how our stairs are defined now, right? Go down here to where our staircase is defined. We have our stairs right here, right? And down here, we change their location A and location B. So instead, why don't we... oh, I see we have a problem here. We have a problem, right? The problem is that we... no, that's fine. We don't really have a problem. Let's just go define our stairs. Well, here's what we're going to do. We're actually going to define our rooms separately before we fill their inventories. Right, so I'm just going to go down here, pass where the rooms are defined, and then we're going to kind of fill their inventories down here. I'll tell you why that is in a second. So we're going to just have all of our rooms be defined right away, like together. Right. Have them all be defined together. Then we're going to actually like kind of add stuff to each room. Let's see here. Separately. And I think Userman might already know why this is a problem. He seems like he's kind of on the ball. Okay, so now we have all of our game rooms being defined, our game areas defined, right here. Depends. It's use extend. Use extend. Don't use append. I think I'm using append because it's a little bit more clear for beginners what we're doing. But yeah, extend basically will take one list, like an inventory, and add another list to it. We actually just say, like, instead of saying append, torch, door, chest, we can say extend and then a list, torch, door, and chest. But it's a little more clear here how it's working, I think. We're adding 3 things to this inventory list. Anyway, so we're defining these game areas, right? And here's why we're defining them before we're filling their inventories. Because we have this staircase here, right? And it requires a room on top and a room on bottom. So I'm going to define them right here, for instance. Let's go here and define stairs, right? And we're going to call it stairs, right? It's going to need a description first, right? Stairs is fine. It's going to need a location A, which is the dark room, and location B, which is a basement, right? But here's what's weird about that. The stairs are an object that are actually in the inventory of both the dark room and the basement. We can see that right here. The dark room, we added the stairs to the inventory, right? In the basement, likewise, we're adding the stairs to the inventory. So if we were to try to add the stairs to the inventory of each room before they existed, that would crash our program. It would say, hey, there's no stairs yet. You can't add that to the inventory. There's no stairs. Right? However, the rooms must exist before we try to make them the stairs location A and B. So we need to have a dark room and a basement for the stairs to work, right? Because they have to have a room at the top and a room at the bottom. But we also need to have the stairs be in those rooms. So it's kind of like a catch-22, right? Like, how do you define the room that contains the stairs before the stairs exist? But you also can't define the stairs before the room exists. Right? We solved that problem here by simply defining the rooms. We made our rooms, right? Then we made our stairs using those rooms, and then we put the stairs in the room. So our order of operations there, it makes that work. We had to make sure that our rooms existed before we defined our stairs. And then we can put the stairs that now exist, because stairs exist now, we can put them into the room. Wait, it says, sorry to interrupt, but today is officially the 20th anniversary of Ed, Edd, and Eddy. Really? Wait. So Ed and Eddy came out the same year as Third Strike? No way. That's crazy. Just says, say room. Room. So now people say it in Canada. We gotta say room. Room, sorry. January 4th, the 20th anniversary. Wow. So I said room, not rum. Rum. Going from room to room. Going from room to room, Dix. Does that make you happy? Going from room to room, guys. I'm sorry, Dix. I'm sorry. So there you go. There you go. What's up, Dix? How you doing, dude? Welcome on board. Okay, so what else can we kind of fix here? Well, we have the door. The door works the same way as the stairs do, right? They need a location A and B. So right now we define the door up here, and then we give it a location A and B. Why don't we do the same way as the stairs, right? We will define the locations A and B on both sides of the door during instantiation. Let's go fix that. Make it a bit more clear how it works. Right now the door has a default location A and B that's just a random game area, and a description that's kind of default as well. Why don't we take all these things away? Yeah. Boom. And make a init method that requires a description for the door, and a location A and a location B. And just like with the stairs, all this function's going to do, all init's going to be doing here, is taking the data you supply as arguments during initialization and attach them to the new object we're making, which is self. So our description is going to be whatever was supplied as a description, as an argument. Our location A is going to be whatever the argument was for location A. And likewise, location B is going to be whatever was supplied as our location B. There you go. So now we have a new way to define doors, which supplies their locations during instantiation. So let's go fix that down here. Instead of saying, we're defining a door, and then later we're supplying the locations, why don't we just define the door right here with the rooms already? So door equals door. It's going to have a description, which is going to be door in this case. We can make it like a red door, We can make it a blue door, make it a big door or a small door. We're going to call it door for now. And we're going to be giving it, the cave entrance as the location A, and B is the dark room. There you go. Get rid of this now. I'm actually going to give the door is locked right here. Okay. Right. Delete these. Boom. Delete the stairs we made here. The old stairs. Boom. Okay. So now we can get rid of this down here too. The door locations are already defined for us during instantiation. Go away. Right here too, the stairs. That's defined during instantiation. The locations. Go away. Sweet. Cool beans-os, man. I see here we have a player. Right? And after he's defined, immediately we're supplying his position, right? The cave entrance. So why not just have the position be assigned during instantiation, right? He's going to be at the cave entrance. There you go. Now you can go change the way that the player is initialized. Let's go check that out. Right here, the player. So when he's initialized, right now he only has no arguments. We're going to give him a position. So he gets an empty inventory when he's created. But also, we're going to say his position is equal to the position argument. Now this class attribute here is redundant. Boom, go away. So now he doesn't default. He doesn't default to nowhere. Instead, he requires a position when he's made. So we're going to say down here that we're putting him right in the cave entrance right away. That's where he's getting dropped off at when he's created. Cool beans. I think our game should completely work right now. We should go test it, right? We have a lot of changes still to make to our code to make it the way I want it to be by the end of today's stream. But we've already made it a bit cleaner by adding this magical init function, this method, to our objects, or to our classes. So, let's see what we're doing here. We're defining a bunch of items at first. We're defining a bunch of, including a chest here. We're supplying a bunch of areas. We're making a door and stairs. And we're adding stuff to the inventory of these rooms. We're making the door locked. And we're making this player as well. I kind of would rather, I think it makes more sense to define the areas first. Just conceptually speaking. So the code's easy to read, right? Let's go up here and we're going to put our items up here. Or our rooms. And then our items. Right. We're going to put the door and stairs actually before the items. Just, it doesn't matter what order you do these in. The order for these is unimportant right now. So I'm going to put them in a way that makes sense to me, personally. So now we're defining the rooms at first, then the door and stairs, then the items. Then we're adding things to the chest. I'm going to add stuff to the rooms first, actually. Because they're defined first. Right. There you go. We actually make the chest. We can make the fridge a chest, right? Because the chest can hold things. Is this a story-based game? Like it is text-based, yes, Duckbiter. But it's not really a story yet. It's really more of an example of how to make a simple text-based game for a beginner. There really isn't much of a plot right now. I'll show you how the game works, though, in a second here. So we define the rooms and do all that stuff. I'm actually going to... that's fine. That's all. We'll do that. We'll define the entrance, add some stuff to inventory. Make the dark room dark by changing the is lit attribute to false. So now it's dark. We're adding stuff to the basement, and then to the chest. We're fixing the door to be locked. Okay, and we're making a player. We actually make the player a lot sooner, I think. Okay. Let's go up here and we can make the player as soon as we've made the areas, right? There you go. So now we're making the rooms, making the player, making the door and the stairs. Right? We're defining our data. I talked before about how every program is made up of two things, right? Data and operations. So we're making our data here at first. We already made our operations up here, right? Our functions we need and stuff. And now we're defining our data here. The cave entrance, the dark room, the player, the doors. Just making everything, right? We're just making everything. We're manufacturing stuff. And then we're adding stuff to the inventories of the rooms. And then to the inventory of the chest as well. We're locking the door. And defining the stuff here. Our game state is like our master object. Right? The game state's kind of like our dictionary that contains the state of our game, our player's progress, basically, right? We need to know what chest is which, we need to know the door. As of the end of today, guys, these are going bye-bye. I decided that as I was getting in the shower today. We're going to fix all this stuff here to make it a little bit more sensible. But anyway, right now we have this game state that saves where everything is and what it's called, basically. Very redundant as it goes right now. The command map takes what the player types in. Takes what the player types in, and then it points to a function to run. Right? So whatever the player typed in, then run this function. That's how it kind of works right now. We're gonna fix that later today. Make it a little bit more sensible, I think. Okay, then the game prints off, you are in a cave. Once all the data is defined, we defined all of our data. Now we're printing off, you are in a cave, and then running this loop here. The loop simply asks the player what they want to do, and then does it over and over and over again until the game ends. So while the adventure is ongoing, right, while the game state adventure is ongoing is still true, then ask them what they want to do with the input method, input function. It's a built-in function to Python. It asks the player for some input. And then, it says, try whatever they typed in. And, if it has a function attached to it, run that function. And then print off a blank line to add some space to the, visuals. And then do it again. Ask them what they want to do, repeatedly. Yeah, snake case. Exactly, user man. Yeah, so basically in Python, the standard is that for variables and that kind of thing, use lowercase where words are divided by underscores. And then for class names, such as treasure chest, use camel case. Camel case means you capitalize the first letter of every word, right? Treasure chest, no underscore there. You don't do it like this, right? You don't do it like this with lowercase like you would with any other variable. It's a class basically from the fact that it is camel case. That's first letter capitalization and no spaces. Treasure chest. That means it's a class in Python. Okay. Cool beanzos. So, let's go down here. Let's just try our program. Let's see if it works still. We haven't tried it in a while. I might have a typo in there somewhere. We have definitely changed a lot of shit. So let's try every command in the game. See if the commands all still work. So let's see here. So I want to look around, first of all. That works in here. Says you're in a dank cave. You see all the items in the room. Let's try and leave the cave. It should stop me. I didn't have the key to leave. Yeah, so I can't leave without the key. Right? So what's happening here, guys, is that it's asking me, it's a while loop, right? While the adventure is ongoing, it's going to constantly ask me what I want to do. And then whenever I type in, it's going to see if what I typed corresponds to a function. Right? Right here. So whatever I typed in could correspond to a function. Right? Like leave the cave, for instance. Corresponds to a function. Basically, all this code does, all of our while loop here, it just says, as long as the game is ongoing, then just ask me what I want to do. And then, try and see if there's a function that is attached to that key, attached to that string I typed in. And if not, if there's a key error because I typed in something that's not in that dictionary, then print off you can't do that. If I can demonstrate that right now, in fact. I can go here and I can say, what you want to do, I want to, fly a kite, right? Well, you can't do that, right? Because it doesn't exist. There is no command yet for flying a kite. So you just can't do that. We got a key error because we tried to use a key that does not exist in this dictionary yet. These are the keys right here, right? Dictionaries are a big, long list of key value pairs. The key is the data used to find the value, basically. So the key is a string in this case, and do a dance. And the value is, the function player.doadance. So you have the key here you can use to look it up. And then when you look it up, you get this value out of it. Flip Steve says, oh boy, the new training stuff for Red Robin is pretty laughable, huh? You don't do training again? Well, I guess that kind of makes sense. Exactly, user man. Make a program with no bugs. You cannot do that. We're going to find out if we add any new bugs, though, during our changes as of today. So far, it's working pretty well. So we're going to try and open the door now. Can't open the door. It's locked. Let's unlock the door. I don't have a key. Right, that makes sense. Let's get the key. You don't see a key. That makes sense. Let me now open the chest. Okay, now I can see a key. Now let's get the key. Okay, I got the key. Cool, now I can see it. I opened the chest. Now we can, enter the door. Okay, it's closed. Can't enter the door because it's closed. That still works. why don't we then unlock the door and open the door? And now can we enter the door? Yes, we can. Okay, so let's look around now. Okay, it's too dark to see. That's good. That's what you want. Awesome. Let's descend the stairs. Does this still kill us or not? Oh, I can't do that. Oh, this is a staircase, right? Descend the staircase. Oh, so I still die by doing that. So you tripped over some stairs in the dark and died. That's funny as hell. So if the dark room is dark, you die, you try and go down the stairs. Let's relaunch our program. Okay, we're going to open the chest, get the key, unlock the door, open the door, enter the door, look around. Okay, it's too dark to see, right? But if I enter the door again and look around, now I'm back at the cave entrance. Let's get the torch. And now enter the door one more time and look around. So now we can see. Now we can see, right? So now we have a door, we have stairs, we have an old record player, and a mini fridge full of Slim Fast. Cool. So let's, play the record. I can't do that. What's the command again for playing it? Listen to the record? There it is. So we have no record to play, right? Let's go, let's descend the staircase. Okay, look around. Okay, so we have a vinyl record. Let's get the record. Okay, and look around. All right, now the record's gone. Perfect. Let's ascend the staircase and look around. Okay, we got this old record player. Let's listen to the record. There you go. Mellow music fills the room. So now we have the record. We can listen to it. And now the game's over. That's everything. We tested everything just now. So the game still works fine. Let's leave the cave, right? Okay, now the game's over. Cool beans. Instead of stressing the importance of good presentation, we have two standards. Picture-perfect plate presentation and a smiling burger. The fuck? That's weird. Anyway, so the game still works. That's good. Let's go improve upon the game, right? So we're going to break it, basically. Whenever you take some code that works and you improve upon it, you invariably will break that code. But by the time you've rebuilt the code, it should be better. All right, so let's look at how our code's working right now and fucks with it. So first of all, we have these loose functions still, such as leave the cave, get the key, get the torch, get the record, listen to the record. So basically, it's mostly the get things, right? The getting functions are still not attached to an object. And that's because these functions, well, we can fix it. In any case, let's just, I have an idea, right? Before we fix that problem, let's look at the way that we handle our commands. So right now, we basically have our commands hard-coded into the game. Like, look around. Get the key. Get the torch. Right? But here's the problem, right? Our problem is that we cannot get this delicious calzone. Look, we have a delicious calzone right there. Right? If I run the program again, right? Open the chest. We can see the chest has a key, a delicious calzone, and a screwdriver inside, right? But I can get the key, no problem, because our game has this built-in, right? I'm sorry, I'm going to lower the timer a little bit. Our program has this built-in command called get the key, and it explicitly points to a function called get the key. But we can get the torch too, right? And the record, but we cannot get the calzone unless we write a method, a function, specifically for grabbing a calzone. Well, that's stupid. Why don't we make the whole thing more flexible by having any game item, or these game items, right? This thing where it's this mold we have. Why not make the game items manufacturable so that you can just get them, right? Any game item can be gotten. How about that? What's up, Mutant? Thanks for the bits, dude. Looking forward to playing some NES today? I know I am. Userman says, plays record. This was a triumph. I'm making a note here. Huge success. I love that song. Who doesn't, though? What gamer doesn't? So, yeah, we have these game items now. Why not just make them gettable? Make them gettable. Right, so, let's just say player. Give him a new function called you know, get. He's going to be able to get things, right? We're going to call this get item. We're going to say it's going to require an item, right? A game item. So we're going to say, you know, if that item is in the room that the player is in, he can get it. How about that? Is that bit sound from F-Zero / Captain Falcon? I'm not sure what you mean by bit sound. The music we're listening to right now is my friend Albdat's ambient music. That's at, I'll show you guys his website here. Go to AUBDAT, albdat.bandcamp.com, and go get this, maybe not this album, but you can go get his most recent album for free. He's a good friend of mine, very cool guy, very nice music for programming and stuff. A little bit laid back, a little bit ambient, a little bit dark sometimes, a bit cold. And I think it's really good for helping me focus. I like it for programming. Yeah, go check that out. Yeah, it's kind of like ambient type stuff. Oh, that sound when bits are donated. Oh, I'm sorry. Yeah, that sound, I don't think it is. It might be. I'm using one of the defaults from Streamlabs. Mutant says, quick question, Venka. Do I need to install DirectX 9 when I install RetroArch? No. No, you do not, sir. Not at all. Just leave that checkbox unchecked. On the installation process. You can use OpenGL. Most people do. Dix is pretty sure whoever made it just wanted to make people say PPPP with straight faces. PPPP. But I don't know if you can be called straight with so much PP in your mouth. Wow. Wow. Dix, wow. All right, so we got this get item method now with the player. We're going to say if game item in self.position.inventory. So if the game item is on the ground in the room that we're in. Right? So if the game item that we supplied is in our position's inventory, then we're going to say, print you got an right, plus game item dot description plus period. Then we're going to say self dot position dot inventory dot remove. So remove the game item from the inventory of the room, and then self dot inventory dot append game item. So take the item from the room and put it in my inventory. How about that? Faust, does anybody here use a French press? Broke my glass one and wondering what kind I should get next. What the hell is a French press? You know what that is. I'm going to say otherwise. Else, if the game item is not in the room, then print off, you don't see that here. So you can't grab what's not there, basically. Here's a problem, right? A problem with this code right now already is that we can't grab things from treasure chests. We only grab things that are on the ground. But hey, we're getting somewhere anyway. We can grab things now that are in the room with us. Cool. Here's what I'm gonna do. I'm actually going to make this function work in such a way that we can actually get things from chests too. Here's what we're going to do, guys. Here's what I think we're going to do. We're going to say, for every item in the room that we're in, is that item a chest? If it's a chest, is it open? If it's open, is the item inside that chest? And if so, get the item. How about that? You could make a function to move items, like remove a pen, to make it easier, since it'll probably be done often. Oh, wait, you are now. I'm dumb. Yeah, that's kind of what we're doing here, kind of. Okay. It's like a bench press, but in Quebec. Wow. Oh, my God. Somebody ban Dix. It's for making coffee, says Faust. Thank you, Faust. No, thank you, Dix. All right, so if the item is in the room we're in, or it's gonna be kind of complex. It's gonna be some complex logic, right? If the item, no, that's not gonna work, right? It's not gonna work. We need to find a way to figure out. We need a Boolean value, right, of if this item is in a chest in this room. I could just get rid of the chest for now. No, let's not do that. Okay, so if a game item, it's in the inventory of the room. How are we going to figure out what chest this is in, this item, in the simplest way possible for a beginner? I could do this pretty easily if I was really going to go ham, but I don't think I want to totally go ham. Okay. How about we try to, let's try to, what we're going to do. First thing we're going to do is look for a chest in the room. So, for, game item in self.position.inventory. If game item, I think you can use type, I think it's built-in. Yes. If type game item is treasure chest, if it's a chest, then we're going to say, if game item dot we're going to say if I can't use game item, right? I'm sorry, because we already have this this argument here called game item. We're going to say for room item in the positions inventory is instance. Oh, thank you, user man. That's probably even better. Is instance rather than type is. I like that. So if room item, if is instance, is it like this? I think. All right, maybe we'll double check how that's supposed to look. Let's go to our docs.python.org. Let's see here. Library reference, built-in functions. Where is instance? Is it just one word like my friend put it in the chat there? It is indeed. Thank you, sir. Okay. So if is instance, the room item, treasure chest. Then we're going to say, if room item dot is open, if the chest is open, and then if we also use and for this. We're going to use a bunch of ifs for now. If game item in room item dot inventory then we're going to say print you got an plus the game item's description plus from an plus the room item dot description, right? So you got blank from a chest, basically. There you go. It's a very long line. Let's see if I can break this up a little bit. How about we use and here? Right? We're going to say, if you, if this item is a chest, then cool. And room item dot is open. And game item in room item dot inventory. A little bit too long still. That's fine. There you go. So kind of complex logic here. A little bit complex. I want a hanging indent here, actually. Oops. There we go. Now we can just say, print off this shite. There you go. Some complex logic there. We're saying, basically, if the item in the room is a chest, and if that chest is open, and if the game item is in the chest, then get the item. That comes for inherent. Thank you, user man. Yeah, very smart. Very smart. Let's see here. Imagine someone letting someone else dictate how your coffee tastes, huh? Yeah, what battle are we talking about? Use a regular coffee maker for coffee, huh? Rather than a French press. Mutant says, hey, sorry, I didn't get your response about DirectX 9. Yeah, you don't need it. Don't need it at all, Mutant. Don't check that box during install. Leave that DirectX 9 box unchecked during install. Okay, so let's see here. So let's print this off. We're going to break a line here, too. It's a very long line here. I was only indenting that far. I think I'm not using Vim. Okay, so let's see here. Get this. Add this as well. There you go. Okay. So now we have this kind of complex bit of logic here. It's saying, if you're trying to get an item, right, you give it the item name you want to get. It says, hey, listen, is this item in a chest in that room? And is that chest open? If so, go ahead and grab it. Then we're going to say, if the room, we can return then too, right? Let's return here. So that'll end our function, right? If we find the item we're looking for, end the function. If we don't find it, then keep checking the other items, right? And then if you don't find it in any of these items in the room, any chests in the room, then see if the item is inside in the room's inventory, naked, like not in a chest. Kind of a complex function, right? But it works, I think, now. So here's what it's doing, guys. One more time. It's when you try and get an item, first thing it does is it checks every item in the room to see if it's a chest. If that chest is open and has the item that we want, then we can get the item that way. I have to actually get that code working though, right? I just printed off the statement, didn't actually get the item. So we're going to, we're going to say room item dot inventory dot remove game item, and then self dot inventory dot append game item. So now we are checking every item in the room first to see if it's a chest. And if the item is in that chest and the chest is open, then we can take the item from that chest and put it into our inventory. Then the function ends. However, if we checked every item in the room and it was not a chest and that chest did not contain that item, then we say, okay, well, is the item on the ground then? Right? Is the game item on the ground? And if it is, grab it that way. If it's not, then just print off you don't see that here. Kind of complex, but what's cool about this is that now we don't need to have different functions for get record and get item and get key and get calzone and get whatever, get the torch. But that means we have to change the way that our entire program handles commands, right? Because right now our program only handles commands based on these hard-coded commands that point to one particular function. But here's what I want to do, guys. I want to have the game change the way it handles commands to being a command and then, having a subject, like an object of that command, like get key or enter door or, leave cave, descend stairs. Right? Instead of just being like hard-coded into the game as a full command, have it be broken into a command and a noun, a verb and a noun. So how are we going to do that? Well, it involves kind of a big change, but you might be surprised by how little is actually changing here. So down here, when we're actually evaluating the command, right, the player punches in the command right here, right? The player command, what you want to do. Then we're saying, the command function is equal to the command map, right here, at the player command key. So if they punched in open the chest as their key, they get this function out. Then we're saying run this function with the game state being supplied. Right? That way it can do its thing. Here's what I want to do though. I want to take this command and split it into two halves. Right? Let's do that first of all. So let's look at our documentation for Python, right? Our Python documentation. We're going to our built-in types, such as the string, the text type. We're going to find a method of string called split. Let's go find that. Where is it at? Okay, is title, lowercase to strings, blah, 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 partition them. What else we got here? Splitting, split right here. So strings have a method called split. And what it'll do is it'll turn that string into a list that is split up at the spaces. So it'll take a string like open chest and split it into two strings, or give you two strings back. One says open, one says chest. And you can also supply your own separator, such as a comma or whatever you want. It defaults to being a space, or any white space, like a blank line, something like that. And it says, probably not going to join for Smash tonight, but I should be good to hop on at some point next week. Let's go. You didn't sleep all night, at least. Yeah, welcome back, Zanzu. You need your rest, man. Happy to hear you're getting some rest. We're going to be here all night long anyway. Whether or not you sleeping. How you doing, man? Hope you're doing all right. Okay, so let's go look at our code now. We're going to use our split method. We're we're going to split this command into two parts. We're going to say, command verb, and we're going to say command verb is a player command dot split. At the 0th index, that's the first part of the split, and then command noun equals a player command dot split, second part of the index. And of course, my friend user manual will tell us that we can actually do this in one line if we wanted to, but we're not going to do that right now. We're going to use two different lines for now. So we're saying split the player command into two strings, and the first string, before the space, is the verb, and the second spot, spot 1, is after the space. That's the noun. So like get chest, or open door. Right. The first part's the verb, second part's the noun. Users, they should use text sequence as the type name instead of string. So much more clear. Yeah. Userman's kind of halfway joking that you can talk about the kappa, but that is kind of weird. It's called a string, right? But that is true of pretty much every programming language, that strings refer to text for some reason. Not sure why that is, to be honest. They said, don't worry, you can just sit here in a tired daze with the rest of us, huh? Don says, will do. What's up, El Soldado? Welcome aboard, dude. I'm not in a tired daze. I took a shower. I'm all fucking energized. I'm clean. I'm excited about playing some NES later. I want to kind of finish this program for now, though. So we have this command we entered. We're splitting it into two halves, right? The verb and the noun. And now we're going to say, we're going to change the way that these commands are evaluated, right? We're going to use the noun to find the object. Here's what I'm thinking, guys. I'm going to write some notes here, right? So, up to this point, we've been using a hard-coded map, a dictionary of whole commands that are, that will reference a particular function or method. Right. From now on, though, I want for each item in the game to have its own map of verbs to methods that work on that item. And the game state will contain a map or a dictionary of noun names to items. Right. So when the user types in get key, the game will use a map to find out what item key refers to. Then it will ask that key how to get it. Right? That's what I'm thinking from now on. That's how our code's going to work now. Yeah, user man, why string be like a sequence of characters? I mean, you can kind of imagine like a string of characters, like a string, like a sequence. But I don't know why it's called string. It's kind of confusing a little bit. Found they ordered some minimalist-looking stainless steel press, huh? Thanks for nothing, fuckers. I'm going to take a shower now. Yeah, nobody had a good recommendation for Faust. Okay, so let's see here. So we have this new idea, right? We're going to be changing the way that commands are handled in our game dramatically. Here's what I do know, right? I do know that every item in the game is going to have its own command map now. Let's go define that right up here. Right. Let's see here. For instance, let's go to our game items, right? Let's make get work, right? So here's our game items. We have to get these, right? Let's just say def, it's going to have, get item. Well, how do we know who's calling it, though? We have to supply the player, right? That should be fine. That should be fine. Or we can supply the whole game state. No, let's just supply the player. So we're going to give self, that's the first argument, because it's a method. Then we're going to take the player that called it, whoever's trying to get the item. Then we're going to, that's really all we need, right? Self and player. So we're going to say, this. Just copy paste this code over to the item itself. How about that? Ta-da! What if the game items want to be left alone? No, we can't do that, dude. I'm sorry. I gotta take it for the team. There we go. So now we're going to say, you know, for a room item in player.position.inventory, you know, if that room item is a treasure chest and it's open and it's self, right? Because now we're using this from the item's perspective, right? So we're saying if self is in the room's inventory, then print off you get it, right? So we're going to say self.description. There you go. And here we go. We're going to say player.inventory.append. So add to the player's inventory. Cool. We're going to say, you know, if self is in the player's player position inventory, then print off, you know, you got that. But then we're going to say, you know, if self is already in the player's inventory, print off, you already have and plus self.description, right? So if we're already in the player's inventory, just say you already have this, or you already have this item. Oh, I'm sorry, guys. I'm getting a little bit tongue-tied here. Okay. Otherwise, you don't see that here. Okay. So now the get item method is attached to the item itself, and we're gonna give it a command map, right? We're gonna say you know, self dot command map equals, well, it doesn't really change per, oh, that's fine. We'll say self.command map equals get is mapped to self.getItem. Okay, now we're talking, right? So now we have this game item, and it has its own command map, right? So now you can get this item. Kind of crazy, right? Exactly, Dix. Yeah, Mutan's installing RetroArch. Did Venka ever say he was going to play on RetroArch? Yes, I'm going to be playing on RetroArch for sure. Venka's playing RetroArch at 9 EST, according to the schedule. Yes, indeed I am. Indeed I am. We're going to be starting off with some Super Mario, some Mario Brothers, the classic, not Super Mario, but the classic one, the arcade version. And then maybe some River City Ransom after that, perhaps. I said what you were going to be playing, you illiterate fuck. Dude, Dix, you don't know what I'm playing, dude. Now you know what I'm playing. Alright, so let's see here. So, we have this game item now has a get command, right? Okay. That makes sense. It's okay, Gator. Alright, I'm over it. So now we don't need this, this get the key method anymore. I'm going to delete it. I'm pretty sure we don't need it anymore. We also don't need get the torch anymore. Okay? You don't need to get the record anymore because they're all game items. We should be able to get them no problem now. I hope. No, I asked what you were playing, just like I did 20 minutes ago. And Zanzibar asked, I'm sorry, guys. I'm kind of having trouble keeping up with the chat right now. It says, success made you a different man. That's all this programming, dude. It's very engrossing. Yeah, we're playing some Mario Brothers, the classic version. That's like the one-screen Mario Brothers. And then some River City Ransom today. Hey, enjoy your shower, Faust. Okay, so now all we have left are two loose methods, functions. Leave the cave and listen to the record. That's fine. Let's go fix our other items, though, so that we can use this noun, verb, or the verb-noun structure. Right, the verb-noun structure. So, for instance, we have these for the stairs, right? Entering the stairs, or, you know, going up and down the stairs, right? We're actually going to say, during init, we're going to say self.command-map equals, you know, ascend is going to now be self.enter. And so is descend, right? Self.enter. So see if this works. Let's see here. So we need to have the player, right? Not the game state, but the player. So it just takes the player, right? I think our new format for methods is going to be taking the player for these commands. Yeah, sounds pretty dominant over the channel for sure. Steve says, all I can think of when someone says assert your dominance is Harvey Birdman, attorney at law, huh? I never did watch that entire series. Okay, so let's see here. We're going to say, if self not in the player's position, inventory. You don't see stairs here. That's fine. We're done. Otherwise, you know, if the player's position is location A. So if you don't have the torch, that's fine. We're going to say, we don't know what the torch is. How about, we're going to temporarily get rid of the ability for the stairs to kill you if you don't have the torch, right? Without the game state, how are we going to see the player as a torch? Well, here's what we can do. We're going to say, you know, player has torch is false, right? But then we're going to say for game item in player dot position player dot inventory. We're going to say if game item dot description equals torch, then we're going to say player has torch equals true. So if they have the torch, then we're going to record they have the torch. Now they're fine. So we're going to say if not player has torch, right? So basically we're saying here if the player is at the bottom or top of the stairs, then we're going to, if they're at the top of the stairs, try to go down the stairs. We're going to first of all say they don't have the torch, right? They don't have the torch. It's false. Then we're going to say, hey, listen, for every item they have, is it a torch? If it is, then it's true. We're actually going to break out of this now. Break means stop doing this loop. If you find the torch, we're done. Break out. Cool. So now, now the player has the torch. We can find out, now we know for sure if they have it or not. Now we can say, if not player has torch, then they die going down the stairs. Right. Oh, we can't change the game state at all. Oh. Why don't we make it an attribute of the player then? Right. Let's go change the player. We're going to go to the player here. Where's he at? We're going to give him a new attribute called adventuring. Right. Self.isAdventuring equals true. Oh, okay. So now we know the player's adventuring based on the player himself, not based on any kind of overall game state. Darkness, my only weakness. Yeah, my only weakness is dark pit, dude. Dark pit. Okay, so now we have this player is adventuring. Now we can go down here, right, and say, while player is adventuring, right? So we're getting rid of the game state. That's our goal today, is get rid of this game state. This big, lumpy game state attribute here. We're gonna try and get rid of this thing, this dictionary, that is. You don't like Hawk Girl dicks? Come on, dude. Hawk Girl's sick. Okay, so let's go up here now with this player's adventuring attribute. Let's go up to our stairs again. Here we go. So now we're gonna say player is adventuring is now false if he dies. Player.isAdventuring becomes false. Now the game's over. Cool beans. Now we can change the player's position here. There you go. And change the position here. There you go. That should work, I hope. Cool beans. Now we have the ascend and descend that are mapped to this enter function. It should be I. All right, let's see. So what else we got here? We have the door as well. So the door should work kind of the same way. Here's the door. It's got quite a lot of methods, actually. Let's fix how these methods work first of all. So now we're not taking the game state. We're taking the player object, right? There's no more game state at all. So we're going to say, if self not in the player's position's inventory. So if this door is not in the room, you don't see the door here. Otherwise, if the door is locked, as the player, you have to check if they have the key or not. That's fine. We're going to say, like last time, player has key is false. And then for game item in player.inventory, if game item.description equals key, then player has key is true. And then we're done. We found the key. Break out of the loop. Now we're going to say, if player has key, then you can use the key to unlock the door. Right? There you go. Otherwise, you don't have the key. Perfect. Door's not locked. Awesome. So that works. Now unlock the door works. Let's try opening the door. No game states anymore. We have a player instead. A player object. There's no game state object anymore. This is like a morning star, I think, yeah. Her superpower was being a bird brain. I'm not really big into comic books, but I watched a episode of Comic Tropes recently. I love that show. Comic Tropes on YouTube. Talk about Hot Girl. Seems like she's a pretty cool character. Okay, so we're going to say, if self is not in the player's positioned inventory, right? The door is not here. If it's not in the room's inventory where the player is at. Okay. If the door is open, then print off, if it's locked, then you can't open it, it's locked. Otherwise, you open the door. Fine. Easy. Now we can enter the door. We have this player, not a game state. There you go. So if self is not in the player's positions inventory, if the door is not in the room the player is in, there you go. If self is open, we're going to say the player's position is going to change, right? Not the game state player, but the player object we were supplied. So previously we would actually fetch the player object through this game state map, the dictionary, right? We're not doing that anymore. Now we're supplying the player explicitly as an argument. We're not relying on this game state anymore for finding anything. There you go. What's the difference between a morning star and a mace, Steve? I know Zanzu knows the answer, but I'm not sure if you do. I don't know the answer. Okay, cool. So now the enter works. Let's go up here and fix our command map. We're going to say self.command-map equals open the door. I was going to use open up, right? Self.open-up. We can also unlock the door, which is self.unlock. We can also, enter the door, which is self.enter. Can I fit that on one line, do you think? No. I'm stupid. Doesn't a morning star just have spikes and shit? Pretty sure morning stars have spikes that maces don't. Those are big round balls of mace. You just put a game state out of a job, dude. Fuck a game state, dude. So director says, oh my, so many if statements, you must be new. Or I am a teacher, yeah, I'm a teacher. I'll try to keep it simple for peeps. Remix says, what is the keyword raise used for? All I know is that it causes an error. It's used for causing a certain kind of error that you want. Basically, you can use a try and accept block. Right, I can demonstrate that real quick if you guys want. Let's go new. We're going to call this, file, save as, raise example, .py. We're going to say, the raise statement is meant to raise an error that you either want to catch with an accept block or whose details you want printed out when your program crashes. Right? For instance, let's say that we have we're going to define our own error. Right? We're going to say a class, shit's fucked. Right? It's going to be based on exception. So it's going to be an exception, right? It doesn't need any kind of special attributes or methods. It's just a special exception that we want to use in our program. It's called shit's fucked. Then we're going to say, we'll say, Vencabot started the stream late, right, equals true. So we're going to say, if Vencabot started the stream late, then raise shit's fucked, right? Let's go run this, shall we? Let's run it right here. There you go. So shit's fucked, right? Shit's fucked. We raised a particular exception that we wanted to raise, right? What's cool about this is that we can say, we can put this in a function, right? We can say, def, is shit fucked, right? Easy. We can supply this, it's going to be, we'll just supply a Boolean, right? Think about started the stream late. Then we can say, try, is shit fucked, right? True. Then we can accept, shit's fucked. And we can not crash. We can say, print off, sorry, shit's fucked. Save that. Or it's even better yet, right? We actually say, like, we can actually use this. I'll just run this for now. It should be, to be totally complete here. There you go. So we caught our own error, right? We defined our own error, we raised our own error, and we caught our own error. And we have our special behavior, like printing off this statement here, sorry, shit's fucked, based on an error that we defined. So raising is good for that, right? It's good for defining your own errors and then dealing with them in creative ways that work for your program. But however, we can also do things like, for instance, we can have a dictionary, right? We can say, our dict equals, red, apple, right? Orange, maybe orange, etc., right? And we can say, try, print off, bananas are, and then the color, right? Our dict bananas. The problem here is that our dictionary doesn't have bananas in it, right? It only has red and orange. I'm sorry, we have colors. Let's just say that, a yellow fruit is, right? I got it backwards. A yellow fruit is, we supply yellow, right? To get our yellow fruit. But our dictionary only has red fruit and orange fruit, not yellow ones. We're gonna have a key error, right? So let's, accept key error and print off, we had a bad key. Oops. I'm sorry, too many O's there, no big deal. Save it. Let's go run it, right? So run our code here. Run the module. So we had a bad key. That's a problem, right? But here's the problem with this accept block. The accept block doesn't really tell us what the key is that was bad. And furthermore, it kept our program from crashing. Maybe we wanted it to crash, right? We don't want our program to keep going when it failed to work. So we can just raise it, right? Raise. That means that whatever error we just accepted, go ahead and just raise it anyway. So we actually used our own behavior to print off a statement. And then we still had the program crash tactically, strategically. That way, we know why it crashed, right? We had a bad key. Oops. Then we raised the error, and we figured out what the key was, because that's the error message. So that's kind of one reason we want to raise things. We might want to catch an error, in an accept block, and do some stuff. Then you still want the program to crash, so you raise it up again. I'm sorry, guys. Let's get back on track. It says weird. So I had RetroArch 1.7.1 installed, but I forgot I had it installed. So I installed 1.75 first. Then I deleted the 1.71 folder, but for some reason now I can't install RetroArch on this PC. Wow. There's a JavaScript framework that uses exceptions for control flow. You can do that in Python too if you want. I don't know, user error as usual. Yeah, it's usually not a good idea to delete a folder for a program when you want it. I mean, you should just uninstalled it through the operating system. Yeah, I don't know. I got installed in my other PC. Yeah, I think if I were you, I would definitely want to. But I didn't use the installer to delete exactly. That's the problem. That's what it sounds like the problem was. Now, again, I mentioned in my message to you that usually I stripped in folder style. Yeah. Here's what I recommend to Mutant. I recommend uninstalling RetroArch 1.7.5 and making sure that this folder is clear. Let me show you the folder here. I'm sorry, guys, for the diversion here. You're going to go to this PC, Mutant, go to local disk C, go to users, go to your name, mine's Venka, go to app data, go to roaming, and then go to RetroArch. Just delete this. That's my recommendation at this point. I'm not sure what you mean by you can't install it, but this folder here holds all of RetroArch's data, basically. That'll give you a totally fresh, clean install. That'll delete everything. You can uninstall the actual program itself, delete everything, and hopefully that'll let you install it. I'm not sure what you mean by it won't let you install it, But hopefully that'll solve the problem. Okay, sorry about the diversion there, guys. Let's exit this or close this and go back to our game. We have another half an hour left to finish this game here. I think it's in a pretty good spot right now, though. So we're adding these command maps to our objects, basically. We're adding command maps to our objects, so we can actually use a new way of processing commands. Right? Before, our commands were all hard-coded in with this big command map object, which would hard code an entire command to a certain function or a method. But I want to change that to be much more dynamic, right? Like a verb-noun structure. Like that way you can just kind of, you can verb every item in the game. So why don't we now go toward, we fixed the stairs and the door to work with the new system, as well as the game items can be gotten now. They can be getted. What else do we have here? We got stairs, we got doors, we have chests as well, right? Here's the chest. Fuck a take item, we don't need that anymore. We have this get instead for the item itself. We can open the lid of the chest though. So we're gonna say here, it takes a player now, not a game state. If self is not in the player's positions inventory, so if the chest is not in the room the player is in, then say you don't see a chest. Right? Otherwise, if it's open, then it's open. That's fine. You can open it that way. Cool beans. There you go. Awesome. Easy. So why don't we now define this command map, right? So we're going to say def init self, give it a description. That's all you really need. We're going to say self.description is the description, and self.commandMap equals open. Going to point toward a self.openLid. There you go. There is no folder. So when you say you can't install it, what do you mean you can't install it? You're getting some kind of error message? What's happening? But that might cause some stupid... Yeah, I agree, user man. I think I'm not going to fuck around with that. Making the same thing as a door, because they open differently, right? They open differently. Anyway. Yeah, because that one has an open up method. This one has an open lid method. In any case, they're very different, obviously. So, that's cool. We have this get description here. That's fine. I want to... that's fine. So when we... how about when we enter the door from now on? We automatically get description. That's what I want to do. So basically, when you enter the door, it says you walk through the door. It changes the position. Now I want to say, player.position.getDescription. Right? I want to get that. So I'm going to actually print that out when they walk through the door. I think it actually prints it out automatically, right? There you go. So when you walk through doors now, you can see what the room looks like on the other side, automatically. It says it installed, but it doesn't actually install anything. It says it's installed, but it doesn't actually install anything. Weird. Okay, good stuff, Mutant. I'm sorry that you had some problems there. Yeah, I doubt it, user man. I'm not sure what the hell the problem would be, but it sounds pretty weird. Okay, so sick. So I think that now all of our items in the game have the... I'm actually going to delete the do a dance method for now. Just keep things straightforward. And look around. Okay, and get item. Because now get is a part of the item itself. Alright, so now every command in the game requires a verb and an object. This should kind of work. NES mini controller on a PC. I don't think so, Mutant. I think you need to have a USB controller. I think those are not actually USB, right? There's some kind of proprietary format on the NES mini. You can buy a little USB controller from 8BitDo. That's 8-bit, number 8, B-I-T-D-O, like Nintendo, 8BitDo. And those are pretty nice controllers. They're pretty affordable, too. Okay, so, get rid of the game state. Fuck that. It's done. Fuck you, it's over. Love is dead. Same with the command map. Fuck it. All right, do a dance. Don't need that anymore. Open the chest, get the key, unlock the door, turn the staircase. All right, these are all handled now. We need to have a record class. No, we need to have a record class. That's fine. The records don't work anymore. We'll fix that later. So let's look at how we're handling this this command now. We're going to fix how this works. We're going to say, well, we need a master list of every item in the game, right? That's all we need now. We don't need to have a game state anymore, but we do need to have like a list of every item in the game. So, why don't we define that? Right? All we need is a list. It doesn't need to be a dictionary. Yeah, that's fine. So let's make a big list. We're going to call this like a game item list. How about like a world list? Thanks for the follow, MSK 2016. We do programming here on Fridays at least. Starting next week, guys, going to be a lot more programming here. Pretty much every day, like on Mondays, Wednesdays, Thursdays, and Fridays. Not on Tuesdays, though. The world list is going to be everything in it, man. It's going to have the... it doesn't need the player, though. It just needs to have the door, the stairs, the key, the torch, the record, the calzone, the screwdriver, right? The record player. Just so we know what all of our stuff is where it's all at. Record player, mini fridge, and the chest. That's everything, I think, right? Don't even need to have the rooms, because we can't really interact with the rooms at all. That Python. Zawarudo. What's up, 27? What's up? Here goes with that Valle. Coming in hot with that Valle. All right, so now we're going to get rid of this help method for now. Fuck that. We're making our program a little bit simpler. Here's what we're going to do. We're going to say, you know, for, well, I would just say, let you know, our target item is none. Then we're going to say, for game item, let's call it world item, in world list, if world item dot description is equivalent to the command noun, then target item equals world item. Break. We're done. Don't keep looking for the item. We found the item we want, right? Now we're going to say, if, you know, do another blank line there. If the target item, or we're going to say if not target item, right? If we don't have a target item yet, it's still none. Then just print off, you don't see that here. Okay. Makes sense. Otherwise, we're going to say, try, we have a command function, right? We're going to say, try the command map. We're going to call this the target items command map. And we're going to call this the command verb, right? We're going to try to find the right function we need from the items command map using our command verb. Hey, welcome back, Faust. Feeling clean. Exactly. We've gotten rid of all of our commands. User's right. We have no more commands now that are one word. Oh, but even if we typed in only one word. Oh, that's a good idea. Yeah, it's going to be a crash. Thank you, Userman. We're going to actually crash our game first to demonstrate your wisdom. We're going to demonstrate Userman's wisdom by burning the world down. Okay, so now we're going to just run this command function with the player. There you go. Sweet. I think that this should be an else, actually. Cut this. Oops. Paste it again. Move this line here. You want to have as few instructions inside your try block as possible. Right? I want to point that out to you guys. So right now we're going to say, you know, try doing this. If you get a key error, you can't do that. Else, which means, you know, if you don't get an error from doing that, then run the command function. I think this will work. I think our game works now. except for Userman's bug. Let's see here. This might be an unpopular opinion, but the menu for RetroArch is hot steaming ass. You actually change it. I think it's kind of nice, but you're right. I mean, it's not, you're right, Mutant. It's not super great, but it is an open source program. No one's paid to make it. It was just made by a bunch of hackers for their own pleasure and for our own, for our pleasure as well. So I appreciate that. I'm grateful. At the same time, you're right. It is definitely a little bit unintuitive. The desktop menu is better. I've never tried that one. I don't mind the default one. I kind of got used to it. Okay, so I think the game's going to work now. Maybe. Let's find out if it runs at all. Run module. Does it run at all? Invalid syntax. I got a typo somewhere. Right here. If the description is equal to key, not equals, you dum-dum. That's for assignments, not for comparisons. The fact else works after stuff like that is one of the things it's really hard to remember at times, because it's pretty much exclusive to Python. Yeah, it's kind of weird. It's kind of weird how else works after things like try blocks and that kind of thing. Try it again here. Run module. Bad syntax again. Same kind of issue here. I forgot to use two equal signs for my comparisons. I'm stupid. Try it again. Game item. Object has no attribute. Game item. Where is this at? What line? Line 136. Oh, right there. It's get. Game item. I don't want that. I wanted self.get. Let's go ahead and game item. Here's my typo right here. I wanted self.get item, not self.game item. There we go. Typos for days. Run it! Missing an argument here for description. Oh, for the treasure chest. Right. Those need a description now. Let's go to find that. Where is it at here? The chest. I want to define the chest right here. Give it the description of a treasure chest. There you go. Coolio. Yeah, Mutant, I give you the ROMs. Oh, you can't load ROMs. Oh. What kind of error are you getting? I have to run this module. Okay, we're in a cave. What do I want to do now? I want to look around, which is not, it's not a command anymore. What happens? Okay, so yeah, I don't see it here. So basically, every command has to be a command and a... okay, yeah, command and a item now. Thanks for not using that shithead dark gray on gray color scheme. The new era of low contrast IDEs blows. I kind of like that color scheme, right? This is actually the default color scheme of idle. But when I use Vim, it's kind of like a dark grayish kind of thing. Let's see. So what do I want to do? I want to get key. I don't see that here. Okay, that's fine. Open chest. I don't see that here. Here's a problem. Oh, it's supposed to be open. Oh, but if it's a two-word description, it doesn't work anymore. Oh, we have two-word descriptions here now. That's fine. Let's reduce them all to one word for now. Or at least have no spaces for now. Right? Calzone, screwdriver, record player, and no spaces, that's fine. Mini fridge, no spaces, that's fine. Chest, that's fine. Use that for now. Serve with underscores, maybe. Yeah, well, we could also just use, I can combine things with split, obviously. But I don't want to do that for the beginners in the audience. Let's just keep everything to one word. Here's our problem, guys. The problem is that I wanted to open the chest, right? But there is no chest. We had a treasure chest instead, which makes sense, right? But here's the problem. We split it up. We split the command right here by spaces into two things, the verb and the noun. So we're assuming that the noun is only one word. There's no spaces in it, right? And that's going to be a bug for sure. Before the end of the stream, maybe not. It's already 8:51. I would like to have the noun be more than one word sometimes. We should be able to do that, though, before the end of the stream here. The game just crashes. Okay, good stuff, Mutant. What would you have to fix? Okay, so let's see here. So let's run the game now. Let's see if we can open chest or not. Hey, it worked! Okay, open the chest. Alright. Now can I get key? Oh, no, I can't. Okay, what's our problem here? Line 147. Game item not defined. Let's see what this bug is here. 147. So this is line 236. So we hit a game item. Right, it's going to be right here, probably. 147 is right here. game item. Oh, it's called a room item. Oh, this would be self, right? It's not. This is self now. Remove self, self. Okay, so we're kind of like, excuse me. We copy pasted this code from the old get item function that was a method of the player, whereas from the player's perspective. Now it's from the item's perspective, so we have to use self here, not game item. That's fine. Likewise, right here, self. Self. And self. There you go. Cool beans. So what else we got here? Everything looks okay now, I think. Hopefully. Sweet, let's try this again. Hey, what's up, Black? In fact, you can always enter regex hell for command parsing. I love regex, dude. I love excuse me. I love regexes, dude. I love them so much I can't even talk. It's buggy. Okay. Okay. I'm not fond of the VS color scheme, huh? So Userman's also a developer, like my friend Ryan. Let's run our game here. Run it. Open chest. Get key. Hey, it worked! Let's fucking go. It's gonna be very annoying for sure, these regular expressions, for sure. Black's annoyed, huh? Finally got myself a copy of Driver 2 just to find out I only have Disc 2. No! Where'd you buy it at? Your local used game store? That sucks. Can I get the calzone now? Get calzone. Hey, look at us, guys. We succeeded. We finally got that calzone. Let's open door. It's locked. Let's enter door. It's closed. Let's unlock door. Hey, use the key. Okay. Let's open the door now. Okay. Let's enter the door now. Okay, we got a problem here. Oh, it needs a game state. Get description needs a game state. Okay. Let's go fix that. Up here, the get description still needs the old game state. Fuck that. We're going to say, if self.isLit, we're going to give it a player too? Needs a player. Okay, that's fine. So if self is lit or, we're going to give it, player has torch value. So we're going to say player has torch is false for game item in player.inventory if game item.description is torch, then player has torch. Break. We're going to say, if the room is lit or player has torch. Then print off the description. That's fine. Okay, there is blank here. That's all well and good. Perfect. Looks good. I was in Vegas, a store called We Play Games. They had many PS1 games that I got. I just failed to see that Driver 2 didn't have Disc 1. That's whack. I should have fucking figured that out for you beforehand. It's not your fault. You should assume when you buy a game, it's all there. It's their job to fucking sort through that shit, man. Fuck. Pizza is life. I wish I had pizza right now. One thing about Python, I cannot catch missing arguments on run until the line is hit. Yes. Yes, indeed, that's true. It's definitely true. You have to run every line to see if you have errors. Okay, so let's see here. Okay, let's run this now. Run it. I'm in a cave. Let me get calzone. Okay, I don't see that here. Let me open chest. No, let me unlock door. Right, unlock door. I don't have a key. Let me open chest. Get key. Unlock door. Open door. Enter door. Okay, so I can't get description. I'm missing one argument for the player. Let me go fix that. Oh, I had to supply the player, right? I'm sorry, I'm stupid. Let's go here to enter the door, right? Enter the door now. We want to print off the room description when we enter the doors. Down here. But it needs a player, though. That's fine. So we know if it's dark or not. Okay, and likewise, let's actually do the same line of code when you go down the stairs. Right? You descend the stairs, okay, that's fine. What we got here? You don't see stairs here, okay, you die. Okay. Let's just return here. Now you can go up and down the stairs. Let's go print off the player position description. There you go. That should be fine. Open mimic. No. We could have to be a random chance to be a mimic. That'd be kind of fun. Ryan comes from a C++ world prior, so programs need to crash, catch fire, and die upon error. Yeah, Python definitely very forgiving. Python is very forgiving. It was a dual game container, so it has driver 1 and 2, plus a driver 3 poster, minus D2 disk 1. Lucky for me, all games I bought work, but Fighting Forces OST doesn't function. OST? What do you mean? One thing I learned about trying to make an object-oriented program text adventure is that you very quickly find limitations of your system if it's not flexible enough. Yeah, well, basically, you want to make a simple game, right? We're making a very simple game here, but you're right. If you want to make a text adventure, you could have basically unlimited possibilities to make your game really, really, really crazy and deep, but at the cost of taking much more time to program it. Well, yeah, but I mean, why doesn't it work, Black? Does it use CD audio and the CD part of it scratched or what? Okay, so let's see here. Let's run this one more time. This should all work now, I think, even though we can't play the record quite yet. Let's, open chest, get key, unlock door, open door, enter door. It's too dark to see. Okay, let's enter the door again. Let's get torch. Does this work? No, it doesn't work. Fuck. The item has no attribute position, huh? Let's see what it is. Line 159. What does that mean? 159. Right here. So if the item is in... Oh, the game item thing again, huh? No, I don't. Self.position. No, I want player.position. Duh. And then player.inventory. Okay. Once again, this used to be from the perspective of the item, from the player. And now the self is the game item, and the player is something else. Gotcha. That should work now. Now it should work. It must be. Strange thing is, if I pop the disc into my PS3, I can listen to the audio file, and they work perfect. Just the in-game music is no bueno. I'll figure out a way to fix it. Really think so, Black Pino? You're gonna fix it? Holy shit. Yeah, play You Die Die. That'd be so sick, dude. That'd be sick. If we had more time, this is our last episode of this season, guys. This is our last time playing with this text adventure. But if we had more time, man, we could have some sound effects and stuff. That'd be cool. Maybe next week. Okay, so let's see here. Save. And let's just run this one more time. Okay, let's open the chest. Get key. Unlock door. Open door. Enter door. Should be dark in here. Let's enter the door again. And get the torch. Now we're talking. Get a torch. Enter door. Hey, now we can see. Cool. Alright, cool beans. I can get the fridge now, right? It's pretty heavy, but no problem. Get mini fridge. Let's go. But we can't get stairs, though, right? Because the stairs are not a game item. Okay, but we can descend the stairs. Descend stairs. Okay. Get record. Okay. And now ascend stairs. Sweet. And now we can't really play the record yet. We have no way to do that quite yet. But cool. Dicks in Python are very nice for making inventory items. Dynamic typing is great for making fast and loose collections, without resorting to too much OOP structure. Yeah, I know what you're saying, Ryan. I think that dictionaries and that sort of thing are really helpful for text adventures especially. How'd you fix it, Black? Before the game would crash every time I finished the first level. How'd you fix it? By just cleaning the disk? You should add an item named bug that when you get in the game just crashes with a very unhelpful error. With just a memory address, huh? Mutants, say thank you. I'll be in a 3S lobby on your Discord server. Gonna go watch a little bit of pre-call. Good stuff, Mutants. I'll see you very shortly. Okay, what you want to do? Our game is done now. We can't beat the game yet because we don't have a way to leave the cave anymore. But that's cool. So it's time for us to stop doing this. But I kind of want to do it for like one more minute while I fix a bug, at least, right? Because we have this bug still that my friend Userman pointed out. If I try to just, look, boom, game crashes. Right? We need to have two words. Why don't we instead go down here? We're going to say, our command split equals player. Well, why don't we just do this? We're going to say player command dot split. That's our command split, right? Then we're going to say, if length, the length of our command split is less than 2. Right? If we have a one, it's only one item long, only one word long. Then print off. Please use verb item command. There you go. And then we're going to just continue. There you go. Sweet. Otherwise, we can say that the command verb is the command split 0. Right. And we're going to say command noun. We're going to actually do a join here, guys. We're going to actually join some shit, I feel like. Is going to be a space dot join command split 1 through the end of the list. I know it's kind of for our last line of code here of the night. We're doing some pretty whack shit. You guys have no idea what the hell I'm doing here. No clue what I'm doing if you're a beginner. Basically, what I'm saying here is use spaces to join the remaining items in the command split, 1 through indefinite, basically. So 1 through indefinite. So basically, every other word in the command is being combined now into the command noun. So now we can have 2-word commands, such 2-word descriptions, such as like vinyl record or delicious calzone or a treasure chest. Right? Hopefully. Exactly, Ryan. For being for noobs, it's a bit kind of intimidating, right? This line right here. Basically, we're saying use spaces to join the remaining words in our command split. Right? This just means every item in the list past the first one. Stop the black magic. No, I'm sorry, userman. I'm sorry. All right, I'm sorry, guys. So this should work now, I think. Let's find out. We can end our stream here. What an awesome season. It's kind of whack, though. I mean, like, our first season of Intro to Python was Pokemon. I think that made much more sense from a beginner's perspective. It's much less abstract. Just numbers, right? It's a bunch of numbers happening. I think that adventure game was kind of a mistake to do for Intro to Python, because it's kind of abstract. Anyway, what do you want to do? I want to open chest. Should be an error, right? You don't see that here. Open treasure chest. There we go. Okay, let's get the key. Unlock the door. Also get the get delicious calzone. Oh, delicious. Awesome. I love a good Python one-liner. Yeah, Python's some really cool syntax. We've kind of been avoiding it. Like list of comprehension is my favorite. Any complex syntax we've been avoiding, but they can be very elegant too. I've been lost since season 2, episode 1. Yeah, I think that the first season was a little more overt for beginners. The idea of an RPG, I think, makes more sense. It involves numbers and that kind of thing. I think that when you start talking about dictionaries and, moving a character around a world and printing out all this text, and I don't know, it seems kind of abstract for a total beginner. But I hope you guys, enjoyed the stream anyway, enjoyed the series on YouTube or here on Twitch. But I'm going to end it here and play some NES games with my friend Mutant. Guys, as usual, if you enjoy hanging out, want to keep the channel on, check my Patreon page at patreon.com/Vencabot. Even $1 is a huge help. Helps the channel stay online, helps me buy gas and groceries. It's a lot of work to stream as much as I do, and it kind of requires that I be home all the time, which means not so much income for me. If you guys help out on Patreon, that's patreon.com/Vencabot. It's a huge help in terms of helping me kind of, stay alive. Let me try and use one word here. There you go. Please use verb item command. Gotcha. Also, you can help out for free by following on Twitch. Tell your friends we're here. Spread the word to your homies. Save clips. Very helpful. You can also check out YouTube at youtube.com/Vencabot archive, or just go search on YouTube for Vencabot. You'll find me that way too. I've got other Python streams there, including the Intro to Python Season 1 in its entirety. That's our Pokemon game. It's much easier to understand for total beginners, I think. That's episodes 1 through 6. We started off very simple. By the end, we had a fully working Pokemon battle. That was kind of cool. You can make your own Pokemon, make your own moves and stuff. It's kind of sick. Also, we have lots of gameplay. We have 1,000 videos on there of retro games, modern games, Third Strike, all kinds of cool stuff. We're gonna be right back, guys, with some RetroArch net play. I'll see you guys very shortly. Python is both the programming language and the attire used while writing it. Adventure games get into nested objects and such pretty quickly, making it more complex quickly. I think that I did it as best as I could to make it as simple as I could, but I do feel like Pokemon made much more sense as a way to kind of grow from episode 1 to episode 6.
Whoa, that was so fucking
I think here it started off very simple
clipping?
and got real complex.
Who is
real
clipping?
Quick.
I have
Whereas
never
Pokemon
seen it hit
made
that
more
deep
sense to kind of go gradually.
What the fuck?
I'm glad you're doing it, Zanzi. Do what you want to do.
No fucking way.
I didn't even think that was gonna work.
Wow.
I've been kind of lazy, guys, about updating the GitHub. On GitHub, we have not only all the code for Season 1, that's Pokemon code, but also variations of the code that are very richly commentated. I put a lot of work into the comments in that code. That would be at github.com, I think, /Vencabot. We have an Intro to Python folder there with all of our code. The code for this adventure game is not all there yet. I've been kind of lazy about it.
Unbelievable. Unbelievable bugs in the lobby.
But all the Season 1 code is all there, including highly counted. I think
wow.
you.
Yo, Galaxy Brain?
The github.com /Vencabot. I think that should go there.
You guys fucking see that shit? Did
If
you
not,
see that? Who's clipping right now?
Let me see.
I'm gonna clip that myself later on this evening.
Is it
Fuck.
github.com /Vencabot? Indeed, thank you, Zanzu. That is indeed it. We have an Intro to Python folder. There we've got our Pokemon code, days 1 through 6. Deeply, deeply commentated. So very easy to learn just from those scripts. If you don't want to watch YouTube simultaneously. And a few of them from this season as well. But not all of them quite yet.